This is the Amp Hour Podcast. Released May 31st, 2020. Episode 494. The Two-Person Rule.
Welcome to the Amp Hour. I'm Dave Jones from the EEV blog.
And I'm Chris Gamble of Contextual Electronics.
What's up, nerd?
Well, isolation continues.
Where do we start?
Got lots of. I've had lots of fun stuff in the past couple weeks, but
Yep. You're still in isolation?
still in isolation here. How about there?
Yeah. No, we're pretty much out of isolation now. Everything's.
Oh,
I'm
great.
not going to say back to normal, but apart from in my life at least, apart from gyms being closed, no, everything's back to normal. Yep.
Yeah.
So yeah.
Okay. Well, you guys wear face mask out or no?
No. I've never worn a
great.
face mask out. No. The face masks are
great.
pretty rare here. Even during the the peak, probably like a month ago or whatever.
Mhm, yeah.
Probably only a few percent of people wore masks. It's just not
Yeah.
really a thing here.
Yeah, I got to say, other countries are doing it a lot better than the U.S.
That's
so,
yeah.
yeah, we don't need to get
Yeah.
into that, but we're just trying to do what we can around here and stay safe. And so I'm working at home and I wear face masks whenever I go out, and it's not a big deal
Really? Is that common?
around here. Yeah, in the
Yeah.
city.
Okay. Right. So do you get strange looks if you don't have one? Is
If
it?
you go to a store, they won't let you in anymore.
Oh, really? Wow.
Yeah.
Okay. Yeah. No,
Yeah.
that's never been the case here. It's like
Yeah.
no. If you come in with a mask, people go, "Whoa, "Are you sick? What's wrong with you?" You
Yeah.
know,
Right?
like yeah. Anyway,
Yeah, it's different all parts of the U.S., but around here,
right?
yep, face mask.
Yeah.
I'm cool with it.
No,
No big deal.
Australia, no worries.
Yeah,
She'll be
good,
right.
Good. Yep, great. I'm glad you guys are doing well.
That's enough of that rubbish.
Yeah, I will say I've been very dependent on overnight shipping. I've been using that a lot lately.
Yeah.
But that's actually more to do. Like I actually use it a lot anyways, and I have to say I'm pretty much addicted at this point. Like
I mean, you were addicted years ago to Amazon Prime.
Prime, yeah, but this is more. That's not overnight. That's not.
I thought Prime was like same day in the US.
Some parts it is. Yeah.
You were bragging
But-
that you had a ladder within hours once. You need a ladder. So you just ordered one on Amazon Prime and it turned up like 2 hours later or something.
No, I don't remember that, but I'm
Yeah.
sure you're right. Yeah,
It was on the show. Yep.
Yeah, I'm sure you're right, Dave.
Yep.
Um,
I'm always right.
no, hard no.
Come on.
Yeah, no.
Oh, boy.
Yeah. So what's going on around there? I mean, I have a lot of issues that I could talk about in general terms this week, but before we do that, what's going on with your electronics life?
I'm playing with vintage hardware. Kind of got
Oh,
a
yeah?
bit
What
of a
kind of
kick
stuff?
out of it. And
Oh, the
1976
Intel thing.
vintage Intel thing. Yeah.
I saw the title. I haven't seen the video yet, so it's on my
okay.
list.
I was quite happy with that. That was fun. I wanted to build it, but I've got a mint in box kit. It's like they're not. I'm not going to say they're ultra rare, but they're not common. And it's mint in box. It's like it's vacuum sealed, all the parts, all the individual kit components from Intel, because you used to buy it as a kit and
Right, but
solder it
What's
yourself.
the value of that? What is the mint in box? And
Mint
don't
in
people usually
box
say that for like resale
Yeah, yeah.
value? And stuff?
Well,
stuff,
it probably could be worth like $500. Like it's not insignificant,
Mm,
right?
Okay.
It's pretty pricey. There are collectors out there who will pay a
okay,
premium.
it's
for that.
collectors. It's not like
Yeah,
someone who's
yeah.
like, oh, I want to use this. It's just like they
Oh
wanna
no,
have
no! You can get
early
built up.
Intel.
That's why I found another one that was built up, that was already built up and hacked and untested. So I bought it, and I, fingers crossed, and if anything, I can do a repair troubleshooting video. But no, it worked. So
Cool.
I'm always disappointed when things work.
Well, let the kids
it's
at
like-
it.
Oh, yeah, right.
Here you go, Sagan. Have a screwdriver in a couple hours with this thing. See what happens.
I've always thought about that. Like I could like get somebody to like put a random fault in a board, so then I have a repair video. But it's got to be like a double blind, well, almost like a double blind thing. Really much. They've got to,
It's like someone opens an envelope and then they hand an envelope to someone else, and that person actually does the thing. Right?
And then that does the yep. So you can't pass subtle clues. I can't get
right. Yeah, I think there is like puzzle finding type of stuff with like troubleshooting, right? You don't want to know the answer.
No, because that just ruins the whole thing, ruins the experience.
I've seen that for like dev board. I think one of the scopes that I've used in the past had like a board. I think maybe the MDO that was sent to me. It had like a test board where it's like, oh, we want to like generate these weird traces or these weird signals rather that you might see, and we want to showcase like what the scope can do. And so they sent a test board that like generated these like runt signals and stuff like that.
Yep. I've got quite a few of those.
Yeah. So it's kind of like that. I mean, and I guess there's like PCB puzzles. I'm surely there's stuff out there like that. I guess that's what one of the DEF CON badges that the toy makers had made. DEF CON 27, maybe?
Mm-hmm.
Yeah, DEF CON 26. It had like a bunch of puzzles on it. So like one of the things was like, even though the chip was soldered onto the back, there's like a SOT 23-6, it was soldered on reversed. And like one of the puzzles was you had to figure out that it was reversed and then be like, oh, and then you reverse it and then like some new function actually came online. So I thought that was pretty cool.
Oh, nice. Yep. That's pretty neat. How many times have you flipped apart like that? And then
Yeah.
Good fun.
Yeah.
All right.
I have not been flipping stuff back. I've been conformal coding stuff recently. That's been a new...
conformal coding, because you're now a high power man. You're now into high power stuff.
Yeah. Not high, not super high power, but
but
dealing with some higher voltages. Not 5 volts. How about that? It's got a little juice behind it. So been conformal coding, and I have actually have the case right here with me. It contains dimethyl ether, acetone, xylene, 1-methoxy, 2-propanol acetate, and ethylbenzene. So,
Gesundheit.
Yeah, I been huffing this stuff. Quarantine's going by way faster for me,
Right.
Huffing my way to freedom.
Right. So you've had some issues. Tell us in roundabout terms, because this is confidential stuff.
Yeah. Some of the stuff. What was the first thing we were talking about? It was one thing was like floating voltages. Another thing was like a bad board house documentation. But what was that first thing we were talking about? I can't remember.
God.
There's been so many.
Expect me to remember. Come on.
Yeah.
Dude, this is bad radio. We should come prepared. We should have wrote this down. We just talked about it like 10 minutes ago, and we've just totally forgotten. Jeez, we're hopeless.
Well, I'll talk about the one thing that was so I was chasing down a problem recently, and I have been using my VNA with the help of Mr. Jeff Mighty Own Kaiser.
Yes, sir.
Yes, sir. And it turned out, so actually it was a mistake on my part, partially, is that I made an assumption. Someone else was ordering boards for me, and maybe you've made this mistake before, hopefully not. But someone else was ordering boards for me, and I didn't send a drawing because they just told me what the stack up would be and all this other stuff, and I was trying to get controlled impedance. And
see it coming, folks. Yep.
Yeah. And it was just a completely different board house. And so I was like, oh, okay, well, and the stack up was completely different too. But let me tell you, after like 2 days of troubleshooting of a very simple board, and just like, it was basically me assuming that I was wrong with the VNA, and Jeff was helping me kind of work through what I was doing with it. Finally, I was like, I looked at this and I was like, there's nothing else that it could be. And I looked at the stack up finally. I'm like, oh my God. It was completely different to the point where the controlled impedance was off by 100%. So
wow. Right. Yeah. So it was like it's supposed to be like you ended up reading like a 50, it was 25. Okay. Yeah, right. So you designed them. So you laid out this test coupon board, and we'll explain test coupons in a minute. So you laid out this test coupon board expecting with the stack up from a particular manufacturer, right? A particular PCB manufacturer, but the person that got the board made used a different manufacturer than what you specified. Yeah.
Right.
Thinking that, oh, well, it's just a PCB, you know?
Right. I don't think it was. Yeah, there was no malice at all. I think it was just really it was
Oh,
a
no, no, no.
miscommunication,
It was just
and then
that.
on my fault, it was
Yeah.
that I didn't
Yep.
send a drawing through. Right. So drawing then would have been like, then the manufacturer would have been like, oh, we're not doing what you're saying
No.
here.
This is
So
why you want me to tell you how to avoid this problem. You
sure, go ahead.
bake in the stack up onto your Gerbers. So you
Oh, I
have
like that.
a specific layer. This is why you have a mechanical manufacturing layer in your PCB file, right? This is what the mechanical layer is for. The mechanical layer is not just for doing your board outline. It's also for putting your manufacturing information around that. So most, or big companies, they'll have like a company template. It'll be like an A4 letter size sheet, template with the grid thing, and all that, and all this information stuff down the side. Look, we need this IPC standard board. We need this stack up. We need
must
this
conform to this. Must conform
to
that,
this.
right?
And I've even put like little pictures of the stack up. So I actually built, I actually draw the stack up and go, this has to be, 10 thou, pre-preg, and this has to be, 1 ounce, a half ounce copper, and this, et cetera, et cetera. And so you specify the stack up, and which you can take from their website. Right?
Yeah, exactly. That's a great starting point. Then you know they can do it.
Yeah. So then if that Gerber, if there's somebody else in the loop has those Gerbers will get sent to another manufacturer that you didn't specify, and they've got an entirely different stack up. Any good manufacturer, and most will, right? They will see this and go, oh, you've got a stack up in here, but this doesn't match what we have.
Right.
So they will actually question it, and they'll ping back to you, and, it's all sorted before the board's actually
made. It's like a catch. It's like a documentation catch, right? Yeah.
Yeah, exactly. But it's got a bit, because if you embed it in a separate file, you might have a text file or a document file or something like that. They can miss that. If you embed it in the Gerbers, it shows up on their screen when they're when the people are doing when you send your Gerbers to the manufacturing house, they have a team that just specifically scans all the incoming manufacturing Gerbers to make sure they're manufacturable. Right. And, then they'll flag any errors and things like that. So they will see that and they will read, they'll just pop up on their screen automatic. They don't have to open some other document file.
Right.
It's all there.
It's in the CAM file. It's in the CAM program. CAM 9000.
It's in the CAM program. It shows up and they will read that stack up and they'll go, yep. Oops. This doesn't work. We can't do this, or we can, but we'll have to order all these different pre-preg materials and this will cost you a fortune, blah, blah.
Yeah.
And then you can sort it all out before it's made, and you spend a week troubleshooting the damn thing, thinking that your measurement thing's wrong.
2 days. 2 days.
2 days.
Very valuable. Very valuable 2 days. Yeah.
Yeah, that's great. Yep. You aren't the first, and you won't be the last.
No, definitely not. Yeah, I think that's a big switch over there too. So I remember when I was getting started too, it was kind of like, I think this is going to be more common because there's so many board houses that are just like, yeah, you just get what you get. It's a PCB. What's the problem? As I was coming to the industry or starting to make boards and stuff like that, there was more and more of the online where you didn't, you basically just got what the stack up was at like an Oshpark or a advanced PCB or advanced circuits or whatever. And so you didn't think about it. And, for a long time I didn't. And for like low frequency stuff that people might be doing. So if people are out there like doing,
which is 90% of jobs, right? Which is 90%.
Totally.
People, you can go your entire career and never have to worry about stack up. Right.
Yeah. And I think you definitely need it for RF. You definitely need it for high speed signaling. You definitely need it if you need like a different board thickness. You probably want to play with it then. But like outside of that, like what else? I mean, is there anything else? I don't know. Like when I was in my analog days, I didn't care at all,
no, for the high power stuff that you're talking about, copper thickness, for example, you might need, one internal layer has to be 4 ounce copper or 2 ounce copper or something like that.
Yeah, that's a good point. Yep. Yeah, it's really anything outside of the, like if you're used to using like a JLC or a PCB way or anyone like that, you're just getting what you get. Maybe you have different thicknesses or whatever, and they tell you what the stack ups are. But
they do, and you can work around those, which is fine. But you just got to know what they are.
Right, and anytime you change something, it's going to go up in cost.
Right.
Yeah, you're not getting that $5 PCB for custom.
And they could change that on a whim, because these are just prototype services, right? This isn't
Right,
their
exactly.
professional service, right? These companies, you get your board for $1 each for a reason.
That's right.
It's because they can change it at a whim, right?
Yeah.
Don't expect them to keep consistency for $1 a board. It's just crazy.
Yep.
Right. So, yep.
Yeah. And I remember Ted Yapo, he gave a talk at SuperCon about, he was just, basically he's making like a crazy fast scope. I think it's like an 8 gigasample scope or something like that.
Right. Yeah, I think I've seen the one. Yeah.
Yeah. So Ted's been on the show. Yeah. And I think he talked about that a little bit. Did you talk about that on the show? Like looking back at the notes, but basically he did a bunch of the same kind of thing, like a test coupon. I remember him showing me the Oshpark test coupon I did, and I was like looking at it, and I was like, "What? Why are you doing that?" But it's the same reason. He's testing basically the controlled impedance, and I think Oshpark uses a FR408 instead of FR4, and there's some benefits of doing that kind of thing, a little bit more, It's all about consistency and stack heights and process stack height versus
tolerance blah, 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 and all sorts of stuff. That's why you might use some Rogers material or something like that, because they've got 100 different types of material, and all they have various specifications. Some are much tighter than others. Some really critical applications you can't tolerate plus minus 5% tolerance on your controlled impedance. Right? You've got to be tighter than that. So you've got to, you've got to pay a lot more for a raw material, a board raw material that that has a greater controlled impedance, and it changes with moisture and all sorts of stuff. It's really, if you're on the bleeding edge, it really matters. That sort of stuff really matters. You can't just use, generic, FR4, whatever you get from your, Asian PCB house. Asian proto house. It's like, no,
right.
You got to specifically specify a particular material, and if they don't have it in stock, which they often don't, they'll have to order it in. So yeah.
Yeah.
Anyway, test coupons. We didn't actually tell. I said we'd explain test coupons.
Oh, sure.
What test coupons are. If you don't know, test coupons are just little strips that you put on usually strips that you put on the outside of your board. Like if you're making a panel, you've got your PCB in there, and then you've got your manufacturing strips top and bottom, so with the socket holes in them that allow your pick and place machine to take your board through the I've done, this is all part of DFM, design for manufacturing.
You made,
panelization videos. I've done several videos on that.
Yep.
How to do that sort of stuff. And test coupons, and there's all this space on the side of the panel, which you're paying for anyway. So it often pays to put a test coupon, which might just have a couple of test traces on it of a certain known width. Label it on the board, by the way. This is like 10 thou width or whatever. So just so you know later, so you don't have to look it up.
Right. You're not when you're doing the testing. The micrometer or something like that. Right?
yeah, exactly. And so you'll put specific, especially controlled impedance traces. And as you said, you might put like an SMA connector footprint at each end. So you can, so it just allows you to hook it up to your VNA, or your network analyzer,
or TDR
so that you can,
as well.
TDR, so that you can measure the characteristics of that trace. Because as I said, there's a tolerance variance when they manufacture these things. Is it 50 ohms, or is it 55 ohms, or is it 45 ohms? You don't know. You want to measure it. Right. So when you get the board back from the test house, and if you're a large company, you will have incoming inspection team which will actually do these measurements for you. If it's that critical, if your company's big enough and this is important enough, then probably have someone dedicated to this job.
That's right. Yeah, exactly. They're just hooking up a VNA all day long, and or
hooking
TDR
up a VNA all day long, and their TDR measuring the the impedance of these traces, making sure that the PCB house hasn't screwed up. Because I've worked on boards that cost hundreds of thousands of dollars each. Right, each
that's
board,
nuts, man.
Right,
yeah,
so if you just get the board from the PCB house, assume it's okay, populate it with $100,000 worth of parts, right, and then you go, power it all up. Oh, why doesn't this work? Oops! It's because they screwed up the stack up at the house, or the tolerance is out, and it doesn't work, and there's nothing you can do about it. You scrap $100,000 board, right?
Or
because you didn't
got the desoldering gun and you're really going to town.
no, because you're that desperate, but No.
Yeah, right.
It's like you can scrap. It can cost you time and a huge amount of money as well.
Okay,
on
Dave.
high-end
Well,
boards.
now you're on the hot seat here. Have you scrapped $100,000 board before?
I didn't know. I've probably scrapped 10. I've scrapped boards in the order of
$10,000 boards.
Tens of thousands. No, so 5-digit boards, not 6-digit boards.
Holy crap! That's still that's anxiety
I know.
inducing.
It's but this is it happens. But this is for projects which have multi-million-dollar budgets.
Of course,
right?
Of course, but still, it's
yeah,
it's tough. It's tough when
tens of thousands
boards
of dollars
go boom, or it's.
Well, this is why
scary.
I've mentioned this before. It became an instant. Doesn't matter who you were. It became an instant sackable offense within the company. They would sack you if you entered the room without proper ESD. And you didn't test your ESD strap. If you went, it doesn't matter, you're a manager or whatever, you're not allowed in that room without your ESD coat, your ESD strap, and you have to test it, and you have to sign the book that you've tested it, and you're allowed to go in, then you're allowed to play with the board, right? Because these boards were so critical to the project that we could lose a $20 million project.
Contract,
a $20 million contract because somebody blew up the board. Right? It's like,
it's interesting too. I think about this now. I think about like the anxiety I felt with Jujutsu saying that. Like that is like really anxiety inducing.
No, it's
but
huge.
Then I think about like I've been in similar situations. I've been handling like hundreds of thousands of dollars of wafers in the past and been around like really expensive.
Right.
I think the thing is you normalize to it. It's like kind of like you do. You get into it. Obviously, there's going to be people that are like. I've been thinking about team size as well. I'm working on very small teams right now, and like thinking. I've been like looking. I like drove past a Tesla today and just thinking about like the amount of integration that's in that. And I'm like, man, there are thousands of engineers. It's like, yeah, Chris, you're not supposed to build a Tesla. You can maybe build one board in a Tesla. Don't be so hard on yourself. Like there are thousands of engineers working on that stuff, and there's testing. And I was just thinking like one board review is like one board in a. It like might have 3 engineers working on it in a Tesla that does like the windshield controller or something like that. And it's got 16 board reviews or PCB reviews. It's like
right.
I don't know. It's just thinking about team size. I've been thinking about team size a lot lately because I've been doing a lot of system integration stuff with small teams, and it's been very stressful. And I'm not sure I want to work on big teams at any time in the near future because I like the hands-on for a lot of different things. But at the same time, like big teams can build big things, and truisms
that's right.
As they are.
You can fly to the moon. Yeah.
That's right. Yeah, exactly. Or or you can have a weather delay, unfortunately. Right. But look, obviously the SpaceX launch, like looking at that stuff, I was so anxious yesterday, like watching just them get ready for stuff, and that's just the launch. That wasn't even, or the pre-launch, I suppose. Like it's not even like all of the pre-work and the testing and the iteration and stuff. I don't know. I've just been thinking about big teams a lot lately, and it makes me a little anxious. I don't know. I'm also locked inside, so I'm anxious about a lot of things.
Have you ever had the 2-person rule for board power-ups?
I have not. What's that?
No. See, once again, these expensive boards, right? $100,000 board with $100,000 worth of parts on it, $20 million contract on the line, right? And you've got that proto, it's built up, and you want to power it up for the first time. They don't let just, Joe Schmo just go corner, hook it up to the lab power supply. No, you've got to have, it's a 2-person rule for valuable boards like this. You've got to have somebody double check your settings on the power supply. To double, just in case you goof it, right? Because you could be having a bad day. You wake up on the wrong side of the bed, and
exactly.
And Murphy's going to get you.
You haven't had enough coffee, whatever it is, right?
Yeah. And so somebody's got to sign off, and you sign off before you power up the board. And it's like, yes, I have checked all these settings. You would have a checklist. You'd have a power up checklist, and somebody would co-sign it. Seriously.
Yeah. No, I like that a lot. I've talked about. I wrote about checklists a while ago, and I'd asked for there are some electronics checklists out there, but the problem is they're just so generic. Or they're so broad. Like
generic ones can't ever work. They can never work. No, it's
a really good idea for like a pre-flight pre-test kind of checklist. That's a great idea.
Yeah. Of course, if you get your board from, your $2 board from JLC PCB and it's got 10 parts on it worth $1, like I mean,
just don't care. But But sometimes. But if you're on I mean, if there's I feel like it's
if there's a tight
deadline. There's cost.
yeah, no deadline, yeah.
Deadlines are yeah.
Time is money.
I've had a couple. Yeah. Yeah.
So
totally. I mean, and like like as much as I love overnight shipping, even waiting 20 hours, is pretty tough. So
and it's not just the time wasted. It could be face as well. Like it could be your reputation. If you're a contractor like you are, for example, and you goof up and like blow up your board. Oh, sorry. You have to admit to them. Oh, sorry. Look, the board blew up. You might make up some lame excuse, but who cares, right? The fact that you didn't deliver means you'll miss the next contract and the next one, and
exactly.
All of a sudden you could be out of business because this $2 board didn't work, right?
Yeah.
So
that's a good point. That's good. I didn't have anxiety about the rest of my business before, Dave, but now I do.
Right.
I definitely do.
Oh my God. Think about it next time. Think about everything that can go wrong the next time.
Gonna be fine. Gonna be fine.
Yeah. It's like, us engineers flying on planes, we can think of 10,000 ways that this plane can, things that can go wrong.
That's right.
Like if you think about it, you would just go nuts and you'd never fly.
It's true. It's true. Yeah, you just got to be like, well, the last flight went okay, so I guess this flight will go fine.
She'll be right.
What could go wrong? Come on.
Somebody's followed some checklist somewhere, hopefully.
Yeah.
And
I just I was kind of lukewarm on the book, but there's a book called Humble Pie that I listened to.
Oh yes, yeah, that's Matt Parker.
Yeah, that's right. Yeah.
The book. Yeah, I haven't read it yet. Yeah.
It's tough to listen to. I think I would have preferred to read it. And the people that it was in a book club thing, and so the people that did read it seemed to like it a lot more than the people that listened to it, because he was reading out strings of digits. But a lot of very familiar engineering things like Tacoma Narrows Bridge and the Millennium Bridge in London, stuff like that. And there's a really great story about the checklists and like a bolt inside of an airplane windshield and stuff like that, and just like how tolerancing matters. That actually was a great story. So I will recommend it at least for that chapter. There's a bunch of stories in there. People, like I said, if you went through engineering school, you're going to recognize a lot of the stories or a lot of the things. There is a lot of programming stuff in there as well. So yeah, it's like I said, I was lukewarm, but it's probably worth reading.
Right.
How do you know who that is, Matt? What is his name?
Matt Parker. I follow him on Twitter. He's a YouTuber. He's a math YouTuber. He's one of the maths YouTubers.
Got it.
Math
yeah.
For you Yanks.
That's right.
Mathematics as opposed to maths. I just find it, even though I'm an Aussie and I'm supposed to say maths, I got it's
tough
too
to
hard
say,
for
right?
me.
It's
I know
it's a bit of a
tough
mouthful,
to I used to be able to do it as a kid, but for some reason I've been conditioned, probably through all this Yankee talk, into saying math now because it's just
Chris
easier.
Is
math.
Having an impact.
Yeah, I know. Bastard. Boy. Anyway. Yeah. That reminds me of the famous engineering fail. I'm going to have to pull up the video for it. What
is the subject of the fail while you're looking it up?
It's a walk. Here
Bridge.
It is.
Oh no, St. Louis.
The Hyatt Regency collapse. The Hyatt Regency collapse.
That was somewhere in the Midwest, Kansas, St. Louis, something like that.
But it's Tom Scott video.
That's the statics problem. So this is the one if you're in statics class and it's like you have a beam and it can support a certain amount of weight, but if you split it in half and have a support in the middle, it can no longer support that amount of weight. That's pretty much all I remember from statics class. That and like pulleys and how much I frigging hate statics class.
Yeah.
Hated it. Oh my God. So glad I don't build bridges. So glad. And other people should be too. It's really just
people died for this thing. If you don't know, it was like they had this suspended walkway, like in a big shopping center or something. The Hyatt Regency Hotel.
It was a hotel,
right?
Yeah.
A big suspended it was a 2-level suspended walkway, and they had these big rods coming down from the ceiling that supported both walkways, one on top of the other. Right. And the design drawings were correct. And they showed you must use one long rod, which goes from the ceiling and then goes through a hole in the top bridge, like the top walkway, goes through, and the same rod goes down and connects to and anchors to the bottom walkway so that both walkways are suspended to the same rod going up to hold it up, right?
Yep.
But somebody who made it went, oh, it's exactly the same if I have the rods going down to the first walkway, and then I'll use separate rods to then connect from the second walkway down to the bottom walkway. That's the same. It's the same weight, right? It's the same load because it's, when the same load on the ceiling, right? And and no, there's
it's very, very different. Yeah.
very specific reasons why that fails.
If you look at
intuitively,
it looks,
it looks fine.
It looks right, but it's definitely not.
It's definitely not.
Which I learned in statics.
Yeah.
I hate statics.
And it's same with abseiling. It's vector loads, right? I'm not using the terms correctly because I'm not a mechanical engineer, right? But if you if you're anchored, your rope is anchored into a rock, right? And you've got two. Let's say you've got two anchors, right? For redundancy in case one pulls out, right? Yep. Okay, so you've got these ring bolts embedded into the rock, right? They actually glue them into the rock, but you've got two of them because you feel safer, right? Well, it's if you put them far enough apart so that it's like a triangle, right? So it's a lot like a Y shape, right? So you've got a sling coming from one, say they're a meter apart, and you've got a sling coming down to one point, and it's joined, and that's where you put your rope into, right? Then that Y, that if you can visualize it, that Y spread, the angle of that spread means you're going to put more force on those anchors. And if you put them wide enough apart, even though you're only 70 kilos or something, right? So it's the same weight on the rope, but the force on the bolts multiplies the further apart you put them, right? Yeah, and it's like you were safer off just using one bolt, right? It's because of the vector forces. Yeah. It's like,
does that exist in electronics, you think? Is that like something where the math looks,
what's the analogy? Oh, what's an analogy?
Yeah, I don't know what it would be.
Oh, leave it in the comments down below.
I would think maybe like parallel resistors maybe are like unintuitive. Well, they still are kind of unintuitive, but I don't know.
Something that multiplies, that is not unintuitive. That you would think, oh, it's the weight. It's the all that matters is the weight on the rope. That's 70 kilo person, right? So therefore, there must be the weight must be split. 45 kilos on each, 35 kilos on each bolt, right? No, that's not. You can get the force multiplies because of the vector angle or whatever.
I feel like something with like resonance, of like LC resonance feels like the same kind of like unintuitive weirdness. I don't know. I don't know what it would be for electronics.
Right, right, because you can get a multiplied voltage due to resonance.
Yeah, exactly.
Right? You can a tank circuit, right?
Yep.
In theory, you can go to infinite volts with a tank circuit, right?
Right.
If your Q factor's high enough, right? Mm-hmm. Well, it has to be infinite. So anyway,
right.
Yeah. If you've got a good analogy to what we're talking about here, hopefully people can visualize this over the radio. They can visualize what we're talking about. But yeah, anyway, we'll link in the video.
Link those the videos.
Yep,
that's
the video to the Tom Scott video.
Lots of flashbacks to intro to engineering classes, I'm sure.
Right. Oh, I've forgotten all that stuff. I just in one ear out the other. If it wasn't electronics, I didn't care about it. It was like, oh God. Yeah. Yep. Do I have to learn this? Why? I can do management classes. How many management classes did you have? Did you have any management classes? Was that part of, you learn the, laissez-faire system and the, all the different management styles?
Engineering? No, not like management classes. There's a lot of like engineering communications and stuff like that. And
right.
There was an investment class at the management school that I signed up for, but that's...
okay. Oh, but that was an optional thing, was it?
That was just for fun, yeah.
Right, okay. Yeah. Yeah.
Yeah.
Yep.
What did you learn at the management classes, Dave?
Have you
learned how to be a manager?
Yeah. I learned I didn't like it because it wasn't electronics. Yeah. I didn't give a shit.
Yeah. So I've been working with like subcontractors on stuff, and it's been really quite positive as an experience, but like it's kind of like taken me more towards the management side of things, and that has been and not on a daily basis, more like just like on a one-off kind of like once in a while kind of thing.
Mhm.
And it has me kind of like it has me feeling empathy for my past bosses.
Right.
Like just because of like the things you have to deal with of like
Yep.
tracking other people's time and
Uh-huh.
I don't know, like giving direction, even just like what
Yep.
should we do next? I don't know. Like someone has to decide that stuff, and when you're in a purely technical role, sometimes it's just like heads down, just go for it. Just
Mm.
you have that one thing to do, and you get to spend all of your time kind of doing that one thing. Uh, it's made me realize that I don't really like management. But there's sometimes you just have bigger projects you need to have some other people on board. But yeah,
Well,
I
this
don't know if
came up on
there's
the EEV blog forum last night,
Mhm.
actually, about
Yeah,
software management, managing
yeah,
software
yeah.
projects and stuff like that. And
What did you think of that, Dave?
yeah, well, because it was directed at me, actually. I
Yeah,
won't go into details. It's over on the EV blog forum, but it's sometimes management decisions are only obvious with hindsight, right? After the project's finished, oh yeah, we shouldn't have gone that direction
yeah, right.
because we had just problem after problem after problem after problem, right? And but at the time, I won't mention the project or what's involved, but like the
Micro
but
supply.
and at the time, it's like, oh, it's just one hurdle. Okay, well, just it seems like
Yeah,
that's the last hurdle to overcome, right?
right, right. But software is like bottomless.
Yeah,
Like you
it's
can
bottomless.
always
It
keep
just
going.
keeps coming. Yeah, yeah, you
Yeah,
can always keep
yeah,
going.
right. And
Right.
it's interesting too. I think that and I think that like a bunch of your products have software, and the stuff that I've been working on has software too. And
Hmm.
like, and it's amazing that it really makes the product 100 times more extensible. Like I can't say what I'm working on, but I can say that I'm replacing a device that has much less of what I've been doing, right? So much less software in
Right.
general. I could say that much.
Right.
And just like the extensibility of it, like, oh my God, like the features we can add in and like being able to
Right.
like
Yep.
access things remotely and just it's amazing. It really is. And it makes me think again about this is kind of what made me think about the team sizes too, of like some of what the modern software enables is having smaller teams in general. You just couldn't do this in the past. You would have
Mm.
had teams that were either would have had a much longer timeline or you would have had a team that was 5 times as big because you just need more people to work on all the different
Right.
pieces, or you have lots and lots less features, right? But now it's just like you can do a software update, you can add new features in, you can fix bugs, you can do all the stuff that
Hmm.
that are still stressors, of course, right? Having bugs in general are
Yep.
stressors, and having more complex products and systems and software are going to introduce more bugs, regardless of what Jack Cancel says. And
Right.
unless you hire him, you should hire him. Yeah, and like all of that stuff, though, it enables. I'm not saying anything that anyone doesn't understand, but like I marvel at it still. It's just that the that how much software enables these days. So
Well, and this was the argument on the forum. It's like, at what complexity of a project do you like take extensibility and modularity and all sorts of stuff so serious that you move from C to C++ and all sorts of fancy, programming techniques, which are great if you're developing Microsoft Windows or something like that, you know,
right,
which is
right.
or writing some
Right, or if
huge,
you're going to be
game or
building,
something.
if you're a company and you're like, hey, look, this is a 20-year product. I'm going to be building 8 different versions of this. Then it's like,
Yeah,
yeah,
that's
man,
right.
invest up
Oh, of
front.
course.
But
That's of
if you
course.
don't know
But if you
that,
got,
like, how would you know up front to do it?
yeah. And it was like, so we were comparing what we're doing on the forum is we're comparing what I now call Dave C, just like Dave CAD, right? There's
Yes, right,
Dave
right.
C. How
Yep.
Dave, this mythical person called Dave, writes his C code, and how somebody else would write it in an extensible thing. So I posted an
Mm.
example from this mythical person called Dave, and right, and it was like 7 lines of code that did a boxcar averaging filter, right?
Oh, okay.
So,
Yeah.
I posted the example of the code. Like it was, 7 lines of code because it just needed to do one simple job and that was it. And somebody went, oh, yeah, this is how I would write it as an extensible thing. And it was like, I don't know, it was like 100, 200 lines long or something. And it was, yeah, you can add all these and you can change the filter types and you can do all sorts
Uh-huh.
of,
Yeah.
things like that. Where it's yeah, okay, great if that's what you wanted to do in your product, right?
Right. No,
but it was
I know exactly what you're talking about right now, because it's basically like Dave C is much like Chris C, I'm sure, where it's like
right. I'm sure we're very us hardware people doing software.
When you move to the next project and you're like, hey, I need to reuse this code, we'll call him Bob, whoever wrote that 100 lines of code. Bob is sitting pretty, right? Bob C or C++ probably is like, he drops it in, it works great, it's got an API, it's tested at the top level, and like it just works, right? Because it's written in that way. And yet I have to go, Chris C has to go and
copy paste and
retest it and just make sure it's working at the top level. Yeah. And,
massage
like you're saying, it's like,
as it's called,
Yeah, exactly. And it's like, it's of course it's better the other way, but it's also an investment, and
it's an upfront investment. It's an upfront investment, and you've got to weigh it up, and also you could also argue that it's an investment in the level of software engineer that you need, right? Because if you're really pushing the boundaries of what C++ can do, doing all this obscure wacky stuff, right, which might be perfectly legitimate in many projects, right? But it's like, oh, gee, is that legitimate because you want to flash a LED? Like, do you need all that? I'm boiling it down to a ridiculous level, right?
No, of course. But I think what we were talking about before, though, too, is like, and when is it due? You know what I mean? Like,
right.
That stuff is great. But a lot of Dave C
Yep.
and Chris C is written because it's due and it needs to get out the door or needs to get tested. And it's like,
that's right.
That's what like technical debt is, of course. That's what every software engineer knows, that one. But like, sometimes technical debt is just going to build up, and it's just, I don't know. And like, it doesn't need to be, maybe it doesn't need to be that crazy. You know what I mean? Like, I don't know.
Right.
I'm sure we get a lot of hate mail for this. Like, I feel it in my bones.
Totally.
You know what I mean? Like,
totally.
I got that ache. You know what I mean? Like, we're gonna get some like
right.
angry, like, because a lot of software people listen, and I'd like to apologize beforehand,
and
but
they're just shaking their head and
I don't care really. I mean, like, I know you're right. You're definitely right.
Of course,
but
but so are we. In certain
I mean,
circumstances.
Here's what I will say. So when people write in, because you're going to write in, the thing I would like to know about is a lot of the resources online are about writing like really high level stuff. I'd love to get better at writing better C, right? And I know that there's some stuff out there about this, but like, it doesn't feel all that practical. And like, I think what I really love, I would love to have like a workbook of like really well written C, and like people like, oh, just go on GitHub and just like browse around. No, I don't want that. I want a book of like really nicely written C with like Chris and Dave C written next to it, and be like, no, this is bad and this is good, and here's how you can get better at it. You know what I mean? And like,
yeah, but there's no. It's like saying here's a good PCB layout, right? Everyone does it differently. True, right? I don't think there is. There's no one textbook. Just like there's no. Everyone asks me, what's the best textbook? There is no one best textbook.
No, I don't want a textbook.
That teaches things the right way. No, I'm saying, I'm using an analogy.
Sure.
Right?
But I just want a collated version. So like for PCBs, what I want like, it's hard to get like a good set of PCBs to look at too. Like I like when you do reviews and you showcase like, hey, this is a great format, or this is a good thing to do. Like, I want that like boiled down over and over and over again, right? Hey, do this thing. Oh, like, and basically it's like we've talked about on the show before of like building a mental library. I want to build my mental library, and I want to do that for C, and I want to do that for PCBs. And I just want like a bag of tricks that I could keep throwing stuff into and hopefully have some kind of recall at some point. You know what I mean?
Yeah, no, of course.
Like, some of that is just called experience, like that's just experience.
But there is no one best way to write software. And if you think there is, you're kidding yourself. And I'm sure the software people would agree. But no, they'll probably think their way is the best way.
Right. Well, there's many hours spent arguing with people on the internet if that is their true thought. Yeah.
Honey, I can't come to bed. Somebody's wrong on the internet.
That's right.
Oh boy.
Classic.
Yep. It is a classic. So there you go.
Okay, so I finally remembered what I was trying to talk about earlier.
Yeah.
Okay, here's what it was. It was being excited when someone else was wrong.
Yes, that's it. That's right. That's right. Yes. Do tell us a summary.
Yeah. So the summary is, I was dealing with a problem with a customer, and not like a problem with the customer, but we were working on the problem together. And basically, my stuff was potentially at fault, and I was very worried about this, and they were very worried about this, and everybody was worried about this.
Did you assume it was your thing? Did you have the spidey sense it was your thing at fault, or was that just the fear thing? Oh, like
I had a fear thing. It wasn't a spidey sense, but the thing
Right.
was, I trusted the person that was doing the testing. They're a very good
Ah,
troubleshooter,
right.
and that is worth 90% in my book, because like if
Oh,
they're
yeah,
taking all the
totally.
right steps and they're telling me the right steps, I'm like, oh boy, it's like this like kind of creeping suspicion. It's getting worse and worse. I'm like, oh
Yeah.
shoot, it's not that. Oh, it's not that. Oh boy, and I'm like throwing out suggestions, and like they
Uh-huh.
were super helpful, and they tried a lot of the things that I asked them to, and like they were awesome.
And it was just looking worse and worse for you.
And it was really looking bad today. And then so finally, I was there, and I asked that they swap out one final board, and the exact same. It was not my board anymore, and the exact same condition happened. And I was just, I kind of celebrated a little bit, and I probably shouldn't have,
Yeah.
because I wasn't happy. I wasn't happy that it wasn't my stuff. I wasn't like, haha, it's on you now. See ya. Right.
Yeah.
But it
of
was,
course.
I was just really happy to, like, we at least had
Yep.
isolating the problem is so important. And we had finally isolated it. It was this one unit that had this problem.
Mm.
And yeah. So I felt a little bad, and I explained myself. I was
So the symptoms manifest itself back to point towards your board, did it?
exactly. And then,
Right.
yeah. Yes,
But it
exactly.
wasn't.
And because it was isolated in that one unit, and what we were doing is basically saying, okay, well, there's other vintage of the board. Like there's my board and then another board, and we were trying on different units. The other board was always working, and
Oh, one of those
and
faults. Oh, I'm sure there's a lot of people at home now nodding, going, "Yep,
yeah,
been there."
exactly. And so it was basically like,
Yep.
hey, the old one works fine, and the new one, which I made, was not working great, and everything we could find, we could not replicate the problem with any of the old ones. And finally, it
Oh,
was a swapperoo with
yeah.
with my board with a different part of it. And finally, we verified, okay, it actually was a different part of the system than mine.
Yep. Jeez, I've been there.
Yeah, and luckily, it had no consequences, because it was just like one
Yep.
unit of many that could be fixed later. So the deadline was
Right.
made, but
Excellent. You had a secret celebration inside. You had a
no, I had an outward celebration, but I definitely
was.
explained
Okay.
myself, because I didn't want to.
Right.
I felt like I was like heck yeah, and then I was like,
Sucked in. It's not my fault.
yeah. So it was.
That's not a good
I
look.
explained that it was not like I was not like happy that there was a failing unit. I was happy that we had
Right.
found and isolated the problem. And I think you had said you have also done something like this before. No.
Oh God, many times. I don't know if I can
Yeah.
remember. I'm struggling to pull a specific instance out. I can just, I
Yeah.
know I can remember the feeling. Oh,
Yeah.
that's all I remember is the feeling of going, oh, it wasn't me. Oh,
Yeah. Right. Exactly. Yeah. Exactly. Yeah.
and it's
Right.
yeah.
Well,
what's-
especially on a $10,000 board, like you're talking
yeah,
about, right?
yeah. It's, something will come to mind, but
I don't know about you, but I usually assume worst case that it is me, and that has gotten me in trouble a couple times. But it also, I think, is the right frame to like then chase towards the problem and say like, hey, if this is me, I think it could be this, and this, and if not, then I'm starting to clear my plate of responsibility. Of course, here I'm still going to help, but you have to narrow down and isolate different elements of a system in order to tell what the actual problem was. And
right.
yeah, I don't know.
Oh, huge relief.
Yeah,
I'm sure
it really was.
lots of people are nodding, going, "Yep,
Yeah.
Yeah.
I don't know.
Been there.
I think troubleshooting is such a quintessential skill, and I wish there was a better way to teach it. I don't know what that would be. I think some of it is just like you're talking about, like getting
There's
a thing
not
that
really.
doesn't
You've
work.
got to do it.
Yeah.
You got to do it, and each experience is different. Each experience adds a
Yeah.
troubleshooting part of your tool. Adds a part of your troubleshooting toolkit.
Yeah.
You know.
Yeah. Yeah. Totally. Right. And it's about, I think it's about rigor as well. Like being able to like
Right.
track your progress, right? If you have a really long troubleshooting streak, you have to write stuff down. I personally have to write stuff
Yep.
down, and
Oh, I've worked on stuff that's taken weeks to troubleshoot.
yeah.
Weeks and weeks. Like, yeah, you can't, as you say, oh, did I test that last week? Like you
Right.
just
Yeah,
don't
exactly.
you
Exactly.
just
Yeah.
don't remember. I'm sure I've gone through and tested things like 10 times, right?
Yep.
Because I just simply didn't remember that I had done it before.
Yep.
And it's and you kind of get desperate going, oh, it's always pointing back to that fault. So you go and test it for the 10th time. And it's, it's
Yeah.
like, it's not that, but everything points towards that. It's some other weird
Yeah.
combination of symptoms somewhere that's causing some obscure fault somewhere.
I feel like something. It's always like it's always good to try. I mean, not always good, but it's important to like list out your assumptions as well. I remember a specific time at a past company where someone was working on a board. So we like had a bad fault condition. It was like I think it was like a oscillating op amp or something like that.
Right.
And for some reason, someone had a heat gun in their hand at the time, and they're like, "Oh, whenever the heat gun hits this part, right about here, it starts oscillating. And then if I get out the cold spray and I spray it here, it stops oscillating." And so we would go back and forth, hot, cold, hot, cold, hot, cold, hot, cold. And it's like, yeah, that is actually a really good way to start to like figure out things that are like temperature sensitive.
You've got to try and find patterns in the
Sure.
failure modes. Yeah.
But it was a complete red herring. And so like, like, how do you know that? Right. It's like, because your entire, like you're saying, you check it 10 times and you're trying the same thing 10 times. When do you stop and think like, oh, I should, try this other thing over here? Like it ended up being a component halfway across the board. It was like a diode or something like that.
Or it ended up being the heat gun, ended up being the noise from the heat gun actually inducing.
Exactly. Right. It was microphonics or something.
The EMF or the EMF from the heat gun
sure.
inducing something somewhere else. And you think it's the heat, but it's not. It's the fact that you've turned on this giant magnet, this giant coil like inches away from your board, right?
Yeah. right.
I've had that where I've worked weeks troubleshooting a board. It turned out to be, the cause of the problem wasn't real, but it was the thing that we were chasing down was caused by the aircon switching on at night. The things at night. So we'd leave it, set up the trigger overnight. I'm sure I've told this story before. Set up the scope trigger, set up all the probes and the logic analyzer and everything. Set it up to trigger overnight because it was a very intermittent fault that only came with time. Yeah. And we found, it was being triggered by, at 2 a.m. in the morning when some system switched on,
Oh my God.
So, it's anyway.
That's terrible.
Yeah.
No, intermittent ones are the worst for sure.
Yeah. Ah, boy. Or the ones that take a long time to manifest.
Yeah. Yep.
Like, that's even worse. Oh, look, you have to work you have to test it for 8 hours before it fails. It's like, oh God.
Right.
You only get one shot, right? You only get one, you have to make one assumption, wait your 8 hours and see if that's the problem. No, then you got to do it again. Wait, that wasn't the reason.
Yeah,
you got to have another guess.
That's when you get good at using data logging and scripting and similar things. It is a important skill to have.
Wow. Anyway.
Yeah.
All right. Have we got news? We got news this week. The most upvoted thing on Reddit. This is where you can upvote things and we talk about them. Yep.
I guess.
Because we've only got like 10 minutes left. TSMC are building a $12 billion factory in Arizona, 5 nanometers. Geez, when I was a boy, it was 5 microns.
Yeah, a little smaller. I don't really have a good feel on because I feel like like all the news releases are about the leading edge type stuff, and I don't really have a good feel for like what's even out there. Like some things are still using 23 nanometers.
I know most things don't need 5 nanometers. It's like like 200 nanometers is fine. For most of the chips out there.
Yeah, well, and that is usually the gate. That's usually the gate width of a single FET as well. That's like the what the nanometers usually refers to. So, and it's usually high density stuff, and TSMC does stuff for FPGA vendors and similar.
Yeah, right. Really bleeding edge.
It's interesting. What I think some of what's driving this is I'm not sure why TSMC went for it, but I read something. Politics.
You don't know? It's politics and it's tax breaks. You can't tell me that the state government or federal government aren't driving this, right? Because they want to onshore this with the whole China situation, right?
Yeah, I think it's that too. Yeah,
and of course,
right. So,
TSMC is not a Chinese company; they're a Taiwanese company, hence the name.
That's right.
Taiwan Semiconductor Manufacturing Corporation or something.
That's right.
T stands for Taiwan. So this is a
T
Taiwanese
definitely stands
company.
for Taiwan. Yeah.
And no, this is a political play. Bet your bottom dollar. And they're probably getting they're probably like paying no tax or something like that. They're probably getting huge benefits to build this plant. I guarantee.
I was also wondering if maybe they were like, sometimes they also chase talent in a certain area, and I think that Intel had some Arizona facilities as well. And like, you think about like, you need process engineers.
Tons of fabs in Arizona.
Yeah,
Arizona Microchip, as in microchip. They're in Arizona.
Right.
Microchip.
Yep. Which is
picks.
It's kind of weird too, because like, fabs need to be like temperature controlled and stuff like that, but like, damn, is Arizona hot? Like, it is just
well, it's nothing you can't solve with oodles amount of power
with compressors, lots of compressors and Freon.
Lots of compressors and Freon.
Yeah. I guess if you have a really solid power source, you're okay. But
you're fine. Yeah, it's all good.
Yeah.
So a lot of you're going to see that this is going to be huge, right? With the whole China thing, won't get into the politics of that, but companies are realizing, holy shit, we're incredibly dependent upon China, so they're going to.
I think it's interesting. I mean, we've talked about on here many times about our own reliance on it, right? I mean, like you and I buy. Of course. Every part comes from there, right?
The Chinese New Year. Every time Chinese New Year happens,
of course,
the world stops, right? I mean, it's
Right. Yep. I just wonder if it's lip service or if there actually will be, stuff outside of China. So
I hope it's not lip service, because I want local manufacturing to come back in every country.
I would love a diversified supply chain. Oh my God. Yeah. Like
every country should be self-sufficient on the basics. It's like medicine and things like that. It's like, well, okay, India and China manufacture 90% of the world's medicines. Okay.
Yeah.
All the raw materials for the medicines. It's like, okay.
Right.
Not good. Like, if you can't get basic stuff like that, if you can't be independent when stuff like this happens, right? This whole crisis thing, and, international travel stops and politics are involved, and trade disputes and tariffs and all sorts of things are going nuts, being flinged around for political power, then it's you really need local manufacturing. So like I said, here in Australia, we do not have there's one, but I'm going to essentially say we do not have a single place to manufacture a PCB. To assemble a PCB,
even a PCB?
Yes, we do.
Wow.
Yes.
Wow.
No, we do not. There's one house left in all of this country that I know of, and they do high-end like, RF military boards, right? You can't buy your prototype. Yeah, if you buy a prototype from them, it's like $1,000, right? They'll make it for you. They'll make your little piddly, 2-layer or 4-layer board for you, but it'll be like $1,000, please, sir. No, they specialize in like high-end stuff in the whole country, the entire
that's
country.
Crazy. Well, a lot of them are shutting down in the U.S. as well, though, because margins are not great.
Oh, they probably are they going to start back up? Business. Is there? Yeah. Will you get tax breaks? Will you get It could
maybe.
Be worth it.
But again. I think it's also that I think like the vintage of when they were started too, like a lot of the it's like mom and pop type businesses that kind of grew over time, and then there also weren't people that were willing to take over the family business type of thing.
Yep.
So and like the business didn't seem like it was that good looking forward,
There was a famous prototype PCB house here in Sydney, RCS Radio, right? And they made like really, bare bones, like none of the solder mask rubbish, right? But if you wanted a double-sided board made, right, that's where you went, 20, 30 years ago, right? That's who you went to get like a cheap, in quote marks, double-sided prototype board made.
How about affordable?
Yeah, affordable board made. And you'd get your double-sided tin plate, thank you very much. And, it'd be plated through, but you get your double-sided tin plate board and, you're happy. And, but it was basically just one guy one crusty old guy running this. Yeah. Everyone knows who I'm talking about if you talk about RCS radio. But crusty old guy running this thing. It was, like if you laid out your board wrong, he would insult you. He would say, I'm not manufacturing that. You put right angles on your traces. Piss off. Wow. It was like he would tell you to piss off because you put right angles on your traces. I'm not going to make that. I'm not going to manufacture that. Bugger off and learn how to lay out a board, And like really crusty old.
This sounds like Dave's mentor or something,
Right, yeah. And anyway, it was famous for this. And once he died,
that was my pop,
right? Yeah. And once he died, like he tried to sell the business, but like no, they tried to sell the business, and nobody wanted it because nobody wanted to take over.
Well, no one wanted to come work with him too,
well, no, he's dead now, So
I know. I'm just saying.
But no, nobody wanted this messy business of making PCBs. Like it's just not glamorous. Like nobody
Right.
No one wants to get up to their armpits in chemicals and making boards and fiberglass dust going everywhere and So
Dave, I'll be honest. I was sitting here soldering parts onto a milled PCB today because I needed something fast.
Right. Yeah.
And I was thinking like, this is terrible, of course. This is soldering onto, there's no solder mask. It's tough to do. It's small. I did small parts for some reason because I needed to be tight, tolerant, or, small size, whatever. And I was just thinking like, I'm okay with this. It wasn't my favorite thing, but I was fine with it. But I had the thought like, this is why people don't want to do electronics in general, right? Like, why not just let someone else solder this together? Like, it's just so much easier to do that. I'll be the idea person, right? That's like the phrase that has been uttered throughout the U.S. for the past 20 years. And, I'll just ship it overseas. What's the big deal? It's like, damn, it is a big deal. Like you got to be close to this stuff sometimes. And it sucks. Manufacturing sucks. I will die on that hill. It sucks, but you got to do it anyways,
And many a Kickstarter has died on that hill too.
That's right. Well, yeah.
They raise their money and think, oh yeah, I'll just toss it over to China and back will come back my magic product from the Oompa Loompa factory. And
right.
Yeah. Oh boy, garbage in, garbage out.
Be present.
Yep.
Exactly.
Boy.
Anything else on the list we should talk about?
Well, I do like the teardown of the Polaroid Insta camera.
Oh, that was fun.
Polaroid
that was fun.
Camera. Yeah, that's an element.
Yeah, seeing 14. The old school, the wire harness on there. It's
just the through hole parts and the individual wiring and just beautiful. Yeah. Would have been a bugger to assemble at the factory. They probably had hundreds of people just there soldering on the line, all these stripping these individual wires, and
manufacturing sucks. Come on.
Yeah, it does. Oh, yep. No, there's not. I haven't watched the full thing, but I don't think there was any flex technology in there, was there?
No, I mean flexible wires.
Flexible wires. Yeah, that is right. Flexible copper wires. There's your flex, Sonny. Oh boy. Yep. And I just love. I got to mention the photo of the. Can we make this the photo for this video? For this podcast. That control room in that Soviet factory.
Oh, I know.
Oh my God, that photo.
Well, it's multiple photos, but yeah, it's a bunch of different control rooms.
The first one is the one I'm talking about. Yeah, it's just
Dave, we don't own this photo, but we'll see what the license is on this photo.
Oh, I'm tweeting.
It's maybe old enough that it might be okay. Yeah.
Yeah, but it's brilliant. Yeah.
Yeah. So it's got, and it's got the actual control diagrams like stenciled with the gauges. It looks like it's probably like a boiler or something like that. But it's got all the gauges there.
Maybe it's some power. It's some power plant. It's some nuclear power plant
probably.
Or something, perhaps.
Yeah.
And it's just
with like mid-century modern furniture and everything like that too. Mm-hmm. It's the guys are wearing butcher hats. I don't understand a lot of what's going on here.
Have you ever built a Mimic panel?
No, I haven't. What's that?
Oh, Mimic panels. Mimic panels are common in all sorts of fields. Please leave it in the comments down below if you see Mimic panels. Mimic MI
Like actual
double A. You
MIC?
don't ask me to spell stuff. I'm an engineer. I can't spell.
Well, I think like mimic, like to copy something. But I
Yes,
don't know if it's
mimic to
that.
copy. A
Oh, okay, it
mimic
is.
panel
Okay.
is like look, it's the 1, 2, 3, 4, 5, the fifth photo down in this one with all the colored
Okay.
diagrams, right? With all the
Okay.
colored diagrams and the gauges.
Oh yeah. I see what you're saying. And people will if they go click on this link. Okay.
Yeah, and so it's like in this case it has the the system diagram there with all the lights and switches and things like that. And a mimic panel is generally not. This is like a proper control panel. The real control switches are there and stuff like that. But a mimic panel is something that like simulates the system. It's usually just like lights, LEDs bulbs back in the old days, and and it would just like simulate the system. Or something like you'd have the silk, as you said, like silk screened overlay to the system. Then you'd have all these LEDs just mimicking what the controllers are doing, and then it indicates. It's sort of like a remote visual display that it's that something's working. It's like a fire panel in a building, right? You don't control anything.
So it shows
mimic
shows the floors and stuff like that.
It shows all the floors and where
third
the
floor
alarm's
has a
gone
fire alarm going. Yep.
Alarm in the toilet because somebody had a durry in the dunnies. And
of course, right, whatever that means.
Whatever durry in the dunny. Yep. Anyway, Aussie people know
mimic panels.
Yeah, mimic panels. Yes, mimic panels. Yes,
yeah, that's cool.
Yeah, this kind of
I see how you're talking about that too. Yeah, it makes sense that when you stencil the thing on it, it's kind of the same thing.
Yep.
Yeah, I don't really get the traditional drawings of.
It's just like you can have this stuff on like a little LCD panel or something like that, but it's not the same as drawing the system in and then having the lights. You can visually see where things flow and
actually,
Dave,
are you looking at that? What's actually really great about the detail of this photo too is that if you look in the upper left of the photo we're talking about, so it has to explain what it is for everyone here. It has all of the drawings. It has all the valves that are looking like they're opening and closing. Whatever.
It's got like pumps, little diagrams of pumps.
Exactly. Yeah, and then in the upper left, there's a line drawing and it says ACC. I'm guessing they accumulate maybe the output of that, but they actually just wrote on the wall to make notes. There's like multiple Sharpie marks all over this wall to make notes of where there's different system problems. Yeah.
Yep. So. Terrific. So it could be a whiteboard and you could write on it and then you could rub it out. Right. And, it's great. Yeah. Anyway, fantastic. It's just gorgeous photo. It's just like, the first one. I just love it. Like, I just like artistically, it's just like the way it's lit and the way
this is Dave's in the lab design coats. Sensibilities coming out.
It's just I like, and I love the guy sitting down at the table and he's got this little mimic panel, side panel down beside him on the floor kind of thing, and it's just.
That's the mid-century modern furniture, like I said.
Right, yeah.
Anyways, we'll let people look at this. We'll let people look at this
furniture. Yeah, that's. It reminds me of the old phone table. Are you old enough to remember the phone table in the hallway?
I never. I know what you're talking about, but we never had one. So.
You never had. So you do know what I'm talking about. The old.
I do.
Yep. Yeah. There was one phone outlet in your house, and it was always in the hallway. And you bought it was a piece of furniture. You bought this, phone table that had a seat, a nice. You sat at it, and there's your rotary dial phone. None of this push button rubbish. And you sat there, and you made your,
Oh man, Dave, you're sounding pretty old. I gotta say,
I sounded pretty old.
Are you saying you would trade this for a Android or an iPhone tab thing in your pocket? Come on, man.
Yeah.
No.
Yep.
Not. I wouldn't trade it for anything.
Totally. I'm thinking about going back old school. Phone
good,
table.
Good. You get one of those. You let us know what Mrs. EEV blog thinks about that.
Oh, absolutely.
You could get your Polaroid camera. Your Polaroid camera with the tear down. Your grainy photos and your disposable flash bulbs, and it costs $85 for a pack of. Well, that's these days actually, but anyways, I'm never going back. Nope, not me.
Right.
You can just steal some of the design elements here and then just make it modern. That's what I'm saying.
Right. Okay. Got it.
I agree. It looks cool. Okay. Last two things. There are two technical things in the subreddit. One is a power topology handbook. It's real. It's got like every, I think someone on Twitter pointed this out to me, but it's got like every type of power topology, which we've talked about in the show before, flyback and buck and boost and all that stuff. But basically explanations. This is basically like a mini book, right? To the point of full phase shifted full bridge converters and Weinbergs and all that stuff.
This is almost identical to a video I was going to do. Like doing an overview of or a summary of all the different types of converters. And then I just thought about it for a while. I just sat there thinking, and I always thought of a new topology. And I went, God, how long would this video be? No, there's like
read through this, man.
20 Zeta different types of bloody, no, it was just, oh God, no, the amount.
Yeah.
My eyes just started rolling in the back of my head at the thought of trying to summarize every different type of power converter topology. It's like, oh my God, no.
Yeah.
No, it's has this got a nice table summary in it of like the pros and cons of each one? Does it have that?
I do not.
It's got a nice brief set of formulas for each one. Somebody's gone, how long did it, who's the author of this? Marcus Zehendner and Matthias Ullman.
Matthias Ullman, yeah.
Matthias Ullman, yeah. I'm an engineer. I can't spell or pronounce.
German. Sound German.
Yep. Anyway, hats off. Like this looks fantastic. I'm just skimming through it now. But yeah, is there like a summary table of like pros and cons of which is best to? Because that was the idea of my video. Is that I'd list the 20 different types.
That's a good idea. Yeah.
Yeah.
Like what should you pull out of the bag of tricks, right? When you need something.
Right. It's, here's it's a summary. Of course, it's probably better as it doesn't need to be a video really. It could just be like a PDF like this that, like just simply a 1-page table that lists 20 different types and the pros and cons. Like, is it isolated?
Give up this video business and just make PDFs. Right. There's a lot of money in PDFs.
Just make PDFs. I could sell it. Yeah, I could.
Yeah, right.
Just like they sell those industry specific things for like $2,000. You can buy this report.
That's right. Yeah.
You can buy this industry report on who's the biggest
report on 5G.
Or who's the biggest microcontroller manufacturer, and there's like 20 customers for this whole report, and they charge like $5,000.
That's why it's $2,000. Yeah, exactly.
Yeah, $2,000. That's cheap.
Yeah, right.
Anyway, yeah.
All right. Last thing is a paper by past guest Dr. Eric Bogatin. TDR and VNA techniques for PCB characterization. You may understand why I was looking at this. So it's a pretty short paper, but it's nice weighted comparison of TDRs and VNAs. So yeah, if you're doing stuff like I was doing, you'll be reading this thing. So,
oh boy, I so want this to have a summary at the end. Then my video's done. I'll just copy this.
You're right.
Please.
Dave on video, he's like, page 85.
Now kids, turn to page 85.
You could just do a live stream where you just read it. Reading
data sheets by the fireplace.
That's right. Yeah.
And a smoking pipe.
Exactly. Glass of apple juice and
right.
Yeah.
Oh my God, this is just no, there's no summary. Oh no.
It's a marketplace for it, Dave.
Oh, there's a marketplace. I'm just mentally trying to figure out how much work it would be for me to go through and really give a definitive list of, oh God, no, too hard. No, I've got to put that in the too hard basket. No, okay. Sorry.
It's all right. Well, we'll find out in 2 weeks whether Dave followed through on this. Tune in next time to learn more. See you then.
Catch you next time.